Morning, everyone. So I'm Vianka, and today I'll be speaking about the 3D printing revolution. So the talk will consist of an overview of 3D printing, some of the processes involved, a short demo of 3D printing, as well as the uses and trends. 3D printing is a blend of art and science, where computer-created designs, mathematics, and mechanical applications are mixed to form three-dimensional objects. It is also known as additive manufacturing, which may sound complicated, but it's really just a small step from spraying toner on paper to putting down layers of something more substantial, such as plastics and metals. These layers then stack and fuse together to form 3D objects. It is used to create complicated shapes and structures with very high accuracy while using less material than traditional methods. The 3D printing is used widely for rapid prototyping in the engineering industry, but with an ever-ending expanding list of materials, the process has shown great advancements in other industries. While 3D printing has grown in recent years, the idea of 3D printing dates back to around 1945, when a sci-fi writer came up with the idea in a short story. His vision was that of a mechanical moving arm, which could replicate his drawings into a 3D format using melted plastic. And while his vision is quite accurate to how 3D printing is done today, it only remained an idea until the 1980s. Today, the capabilities of the technology are very vast and expanding by the minute, with new developments announced regularly. It is truly revolutionizing a number of industries and will be unrecognizable in the years to come. So before moving on to the technical aspects, it's important to understand a few key terms when it comes to 3D printing. Computer-aided design is the virtual modeling process used to design parts before 3D printing. An extruder is a motor with gears which pushes filaments towards the printer's hot end. And a filament is basically the fuel for the 3D printer. And nowadays, there are a wide variety of materials such as plastic, resins, and metals. A slicer is a program that turns 3D designs into a list of commands that a printer uses to print the model. Now, without a slicer, you can't 3D print. The instructions need to be in the form of G-code. G-code is a programming language used for CNC machines. It commands the printer to perform actions such as moving the components, extruding filaments, changing the temperatures, etc. Lastly, infill refers to the interior of the printed object. It can be controlled with two main slicer settings, namely density and pattern. These settings will affect the shape, structure, and solidness of your printed object. Moving on to the technological aspect, there are several types of 3D printers, the most common being FDM, SLA, and SLS printers, increasing in cost and the level of detail that they print. When it comes to the software, one would need CAD software to create the 3D model, but you can also use existing 3D models if you don't wish to design one. Then there's slicing software to digitally cut a model into flat layers, which the 3D printer will then print one by one. And optionally, software to operate your printer remotely. The first step of any 3D printing process is 3D modeling. All modern CAD software will allow you to export models into STL files, which is the industry standard for 3D printing. Once the model is created, it's time to slice it. And quite literally, the software slices the model into layers and further determines how each layer will be printed in the best time and strength. A slicer software takes 3D CAD model, which is generally in an STL format, and then converts it into G-code. Once the model is sliced, it's sent off to the 3D printer for the actual 3D printing process. The printer generally acts the same as a traditional inkjet printer, where a nozzle will move back and forth while dispensing the material layer by layer. waiting for that layer to dry, and then adding the next level. It will essentially add hundreds or thousands of layers on top of each other to make a three-dimensional object. Once the object comes off the printer, its support materials are removed and may also be sanded, painted, and plated to improve its functionality and appearance. And I like to run through a quick demo of 3D printing. So one of my friends actually has a 3D printer and was kind enough to model and print a DVD desk stand for me. And you can all have a look at it as being passed around the room. So this is the model that he created. And these are just some videos to show you how the 3D printer actually works. The values and advantages that 3D printing offers makes it one of the most promising technologies available. One of the major benefits is the fast design and production of objects. Next, the ability to have so much freedom in the design is a huge advantage of 3D printing. For any business, cost effectiveness is also an extremely important factor. And while there may be high startup costs involved in purchasing the machinery, in the long run, these costs are offset by other savings made during the manufacturing process. Since this is an additive process, the materials are also reduced and the labor costs are also kept low, as you only need an operator to start the machine and to start the operated process when creating the uploaded design. The 3D printing builds products with very little waste. Depending on the material, the waste can also be reused. For example, plastic materials can be melted and cooled down over and over again. 3D printing is also showing great promise in fulfilling a local manufacturing model, whereby products are produced on demand in the place where they are needed, eliminating huge inventories and unsustainable logistics for shipping. The evolution of 3D printing has seen a rapid growth in the number of companies adopting the technology, and applications and use cases vary across industries. 3D printing has many uses in the architecture industry, from building concept models to building entire structures. With 3D printers now capable of printing walls and even processing cement, the technology could even reshape construction. A few years ago, Canada's first printed home, the Fibonacci house, became the first of its kind to be listed on Airbnb. And recently, the first 3D printed house in Germany was created using concrete 3D printing. 3D printing is also beginning to transform the audiology space, with high volumes of custom ear products like hearing aids, protective plugs, and earphones being manufactured. Dentistry has also been one of the most prominent uses of 3D printing, with desktop printers an increasingly common sight in dental labs and practices. As surgical techniques improve, surgeons also need more advanced instruments to support their procedures. And whether this is customizing the instruments to the surgeon, to the patient, or to the procedure, metal 3D printing makes it possible to tailor these tools. The sport footwear industry has long relied on technology to optimize the performance of their products. Large brands like New Balance, Adidas, and Nike have even recognized the power of additive manufacturing. Not only can 3D printing technology alter the production of textiles, it will also improve the opportunity to create textiles that are, for example, bulletproof, fireproof, and capable of retaining heat. Most printers for 3D food use a similar technique to regular 3D printers. They deposit a food-safe printer filament like chocolate onto a build plate. Some cases include cruelty-free, environmentally friendly meat using plant-based materials, space food, and food for people who have difficulty chewing. Sushi Singularity is a Japanese restaurant in Tokyo that aims to revolutionize sushi and the restaurant experience by 3D printing meals based on your unique biodata and nutritional needs. As 3D printing matures and more materials become available, the consumer goods industry is opening up as well. Hobbyists are using this technology to create all sorts of wonderful and wild projects that were previously all but impossible to make at home. With 3D printing libraries so easily accessible, 3D printing communities and marketplaces are continuously expanding, and ideas are never ending. As the technology continues to evolve, the future is brighter than ever. Scientists all over the world are working to accomplish a variety of goals, including working to find a way to colonize other planets and make it suitable for humans to actually live in space. 3D printing is one of the leading technologies being considered for space colonization, thanks to its adaptability, cost effectiveness, and of course, the ability to locally produce materials. In addition to this, the 3D printing technology using heat-resistant metal alloys is revolutionizing trial and error rocket development. In the healthcare field, there are even more high-impact use cases currently in development. Being able to create new organs has for decades been a dream for scientists working in regenerative medicine. Not only could 3D printing organs save lives by addressing the transport shortage, they may even offer newer, safer ways to design and test drugs. There's also hope that 3D printing can provide new solutions for prosthetics where cost and customization were issues. There isn't just a demand for housing across the world, there's a demand for affordable housing. And while a limited number of 3D printed homes have been built worldwide, the idea has been gaining popularity. And in time, 3D printed homes could very well be a solution to housing shortages. In the world of 3D printing, there really is a revolution, and it's a tremendously exciting one, changing entire industries along the way. If everything from prototyping to mass producing is made exponentially quicker and more cost-effective than ever before, then integrating 3D printing into business seems like a no-brainer. It promises to equip entire industries with more potential to innovate, opening many exciting doors along the way. Thank you all for listening to my talk.